Hello, my name is Yuri Alostrix, and I'm going to be your instructor for the Get a 5 AP Calculus BC series of lessons. Today we're going to start off with trigonometric substitution. Alright, so let's get started. So today we're going to be focusing mainly on the integrals involving sine and cosine. We'll leave the integrals of secant and tangent for the next lesson. So when you're taking the integral of sine x times cosine x dx, usually you'll do u substitution, set sine equal to u equal to sine, and then the du of sine of x equals cosine of x dx. So you can just take that out, and that's equal to u, and the integral, well, you see where I'm going, right? So today we're going to be showing situations where you can't necessarily do u substitution until you've moved your sines and cosines around a little bit. So what we see here is we have 1, 2, 3 rules that apply to most, if not all, integrals involving sine to a power and cosine to a power. So let's take a look at rule number 1. So it says, if the power of the sine is odd and positive, save one sine factor and convert the remaining factors to cosines. So let's keep reading through the rules, and then we'll move on to the examples. So rule number 2 says, if the power of cosine is odd and positive, save one cosine factor and convert the remaining factors to sines. So this is basically the same idea as what we just said. If cosine has an odd exponent, so cosine cubed, cosine to the 5th, cosine to the 7th, right, and so on, you'll take one of those cosines, keep it to yourself, and then you'll convert the remaining cosines into sines. So now let's move on to rule number 3. It says, if the power of both sine and cosine are even and non-negative, make repeated use of the appropriate trig identities. So that might be the most confusing of all of the rules, but trust me, it's not as hard as you think. What's basically saying is that if the power of sine and cosine are even and non-negative, meaning if the power of sine and cosine are either an even number, so 2, 4, 6, 8, or 0, and non-negative, so also including 0, not including -2, -4, and so on, then you can use the appropriate trig identities. So usually this means power reduction formula. So let's get into some examples. Alright, so let's start our first example. We're going to take the integral of sine cubed of x dx. We're going to keep our integral, and we're going to have 1 sine of x, and then we're going to have sine squared of x dx. Right, so what we're going to do is we're going to take this over here and we're going to plug it over here. So integral of sine x times 1 minus cosine squared x dx. And now we're just going to use u substitution and integrate. So in this situation we're going to say that u is equal to cosine of x, and then du equals negative sine x dx, right? And then we have our sine of x, or dx, so let's just add in that negative. So now we're going to do our u substitution. We have negative integral of 1 minus u squared du. Alright, and let's just integrate and then plug in cosine again. So we have negative u, because we're integrating in terms of du, not in terms of dx. So it's gonna be u minus, and remember, raise the power divided by the power, so 1/3 u cubed, always plus c, don't forget that plus c, guys. And so now we're going to just plug cosine of x back into our equation. So we have negative cosine x plus, right, don't forget to distribute the negative, plus 1/3 cosine cubed x plus c, and this is our final answer. And if you want, you guys on your own can go back and take this function, or sorry, this expression, and you can derive it, and you will very likely come out to sine cubed of x dx. If you don't, then I clearly made a mistake somewhere. So that's our first example. So now let's move on to example number 2. Alright, so let's move on to our second example, where we're going to utilize rule number 3 that says, if the power of both sine and cosine are even and non-negative, make repeated use of the appropriate trig identities. So what we're going to use this time is we're going to take the integral of cosine to the 4th power of x dx. And you might be asking yourself, well, where's the sign? Well, it says that if the power of both sine and cosine are even and non-negative. Well, in this situation, the power of sine is 0, and therefore it is both even and non-negative. What we have to do is we're going to use a trig identity known as the power reduction formula. So let me write that out for you guys right now. Alright, so how we're going to use this, we're going to take cosine 4th x and we're going to split it in 2. So basically we're going to say 1 plus cosine squared, cosine 2x over 2 squared, and then we're going to do everything again. So let's take that step. Alright, so what I want to do right now is I'm going to basically simplify this this expression to a point where I can once again use my identities squared, right? So basically I just FOILed the top, and that's all over 4 because 2 squared is equal to 4. Now what I'm going to do is I'm going to take this 1/4, I'm going to take it all out, I'm going to be left with 1 plus 2 cosine of 2x plus cosine of 2x squared. And what I want to do here is I have to reduce this power once again. So I'm going to use this formula and plug it into here, and I'm going to get, instead of 1 plus cosine of 2x over 2, I'm going to get 1 plus cosine of 4x over 2 since the x is equal to 2x. So let me do that right now. Okay, so now that we've done that, let's not forget our dx's. Almost forgot that completely. So now that we've done that, we're set to integrate. Alright, so what we're going to do is we're going to keep this 1/4 over here. And we're going to just integrate what we have. I'm going to take this part and separate it into a different integral so that we can integrate it separately, because some things sometimes get complicated. So the integral of 1 dx is just x. The integral of 2 cosine of 2x, well, let's just think about this for a second. The integral of cosine of 2x is equal to sine of 2, well, equal to 1/2 sine of 2x, right? So multiplying by 2 is going to leave us with sine of 2x, so that's just plus sine of 2x. And we're going to close the parentheses on that, and we're just going to do this. 1 plus 1/8, because 1/4 times 1/2 is 1/8, integral of 1 plus cosine of 4x dx. Okay? So over here I'm going to distribute my r 1/4, and over here I'm going to integrate what is 1 plus cosine of 4x dx. So we have x over 4 plus sine of 2x over 4 plus, alright, so let's do this. So the integral of 1 in terms of x is x, so x over 8, right? And now we're going to do the integral of cosine of 4x. So the integral of just cosine is sine, and the integral of cosine of 4x therefore would be sine over 4. So plus, and this is going to be over 32. So sine of 4x, right, over 32. And since we've already finished this, we're just going to add the plus c there, and that's about it. But what I'm going to do is I'm going to put some of our terms together. Alright, and now let's just show our final answer. I'm going to get another piece of paper, just so that it's easier for you guys to see the progression of the steps. So our final answer is going to be 3x over 8 plus sine of 2x over 4 plus sine 4x over 32 plus c. Thank you guys so much for joining me today to learn about trigonometric substitution. Hopefully you learned something new, and I'll see you in the next video.